Hello students, welcome back to my channel once again. So again we are back with CBSE grade 10 probability. So today that this is the part 4 discussion. So we will solve more problems on probability topic. So earlier we have solved some problems on probability like rolling the dice two times or rolling the coins two times. So now we will dive into the more problems of probability that will be covered in CBSE Board Grade 10. So the first topic is finding the probability of sum based on fish and the sum based on tossing three coins. So earlier we have learned about tossing, we have seen the problems on tossing two coins. Now we will solve some problems based on tossing three coins. So let us take a look at the first question, that is the fish problem. Gopi buys a fish from a shop for his aquarium. The shopkeeper takes out one fish at random from a tank containing 5 male fish and 8 female fish. What is the probability that the fish taken out is a male fish? Okay, so here the number of all possible outcomes of the experiment here is the total number of fish. So how many male fish are there? 5 male fish and how many female fish? 8 female fish. So total number of fish will be 5 male fish plus 8 female fish, right? So that is equal to 13 fish. Now they have asked the probability that the fish taken out is a male fish. So let E be the event that a male fish is picked up. So now how many male fishes are there? So that is 5 male fish. So number of outcomes favorable to E, that will be equal to 5 here. So probability of E will be equal to number of outcomes favorable to E divided by number of all possible outcomes of the experiment. So probability of E will be equal to 5 by 13. Now this is a tossing the coin 3 times problem. A game consists of tossing a 1 rupee coin 3 times and nothing its outcome each time. Hanif wins if all the tosses give the same result, that is 3 heads or tails, and loses otherwise. Calculate the probability that Hanif will lose the game. Okay. So here let us take a look what is given in the question, that tossing a 1 rupee coin 3 times. So when a coin is tossed 3 times, so we know that when a coin is tossed 3 times, the possible outcomes are, so we have already seen these possible outcomes earlier in my videos, right? So the possible outcomes are 3 heads, head, tail, head, tail, head, head, tail, head, then head, tail, 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 and tail, tail. So there are 8 outcomes. So total number of possible outcomes equal to 8. Now we need to find out the probability that Hanif will lose the game. So let A be the event that Hanif will lose the game. Now what is the condition given? Hanif will win if all the tosses give the same result, that is 3 heads or 3 tails, otherwise he will lose the game. So Hanif will lose game if all tosses do not give the same result. So winning criteria is it will give the same result. So the losing criteria will be to not give the same result. So what are the cases here for not giving the same result? That is, we have to exclude 3 head and 3 tail. So the rest, that is head, tail, head, tail, head, head, tail, tail, head, head, tail, tail, and tail, head, tail. So outcomes favorable to A are These are the outcomes, right? So now the number of outcomes favorable to A is equal to 6. So the probability of A will be equal to 6 by 8. So if you simplify, we will get 3 by 4. Now the next topic of finding the probability of sum based on tossing one coin and sum based on playing cards. So the question is, why is tossing a coin considered to be a fair way of deciding which team should get the ball at the winning of a football game? Okay, so this is a very good question. Like, why we should always consider that tossing a coin is a fair way game. Okay, so this will give you a fair chance of uh, who will who will start the beginning of the football. So it is also used in the cricket match also. So when we toss a coin, the outcomes head and tail are equally likely. So since there are only two options, we will get either head or tail. So the outcomes are equally likely over here. So either head or tail. So outcomes are head and tail. So these two outcomes are equally likely to occur. So the result of an individual coin toss is completely unpredictable. So there is no biasness. So anything can come, whether head or tail. Now coming to the next question. Now this is a card based question. 5 cards, the 10, Jack, Queen, King, and Ace of Diamonds are well shuffled with their face downwards. One card is then picked up at the random. Now, what is the probability that the card is the Queen? Next part is, if the Queen is drawn and put aside, what is the probability that the second card picked up is an Ace? And the part B is a Queen. Okay. So let us take a look at the problem, how we are going to solve this. So 5 cards, what are there? 10, Jack, King, Queen, Ace of Diamonds. Okay. So these are the 5 cards. So it is already shown over here. 10, Jack, Queen, King, and Ace cards. So total number of possible outcomes here are 5, since there are only 5 cards. Now what is the probability? So since it is a diamond, so what is the probability that the card is a Queen? Okay, so let A be the event that the card picked up is a Queen. Okay, so out of these 5 cards, what is the probability of getting a Queen over here? So there is only one Queen. So number of outcomes favorable to A is equal to 1 over here. So the probability A is equal to 1 by 5. Now let us take a look at the next part. If the Queen is drawn and put aside, what is the probability that the second card pick up is a Ace? One thing over here, in this case, since they have mentioned how many cards are there, so in this case we will not consider the total number of cards, that is 52 in a card playing game. Oh, so since they have mentioned the cards which are there, so that's why we have considered only 5 cards over here. So don't confuse that. Here also we need to take the 52 cards. Since they have mentioned that 5 cards they have taken, so we will only consider 5 cards over here. Okay, now coming to the part 2, that if the Queen is drawn and put aside. So that means, so when if the Queen is drawn and we have kept it aside, so now let us take a look. We have removed the Queen now. So now, since one card is gone, so what are the total number of possible outcomes? That is 5 minus 1. There will be 4 cards remaining. Now, what is the probability that the second card pickup is an Ace? So let B be the event that the card picked is an Ace. So there is only one ace card. So number of outcomes favorable to B is equal to 1. So the probability B will be equal to 1 by 4. Now, what is the probability that the second card pickup is a queen? So let's see with the event that the card picked is a queen. So is there any queen card in this case? Because we have already put the queen card aside, right? So there is no queen card. So number of outcomes favorable to C is equal to 0. So P probability of C equal to 0 by 4, that is equal to 0. Now we will discuss about the topic finding the probability of sum based on playing cards. One card is drawn from a well shuffled deck of 52 cards. So here they have considered 52 cards. Find the probability of getting a king of red color, a face card, a red face card, and finally the jack of hearts. Oh, there are more, a spade and the queen of diamonds. So let us check how we are going to solve it. So there are 52 cards in a pack. So these are the cards arrangement of 52 cards. Now total number of possible outcomes equal to 52. So now we need to find the probability of getting a king of red color. So let A be the event of getting a king of red color card. So now here we know that out of 52 cards there are 26 black color card and 26 red color card. Now if we divide, so there are 13, there are 4 groups in the card, right? So one is diamond, one is heart, another one is spade, and the final one is club. So the bottommost one is the diamond, then that is of red color card. Then we have the heart of red color, and then the second row is the spade card, and that is of black color. And at the top we have the club card, which is black color. So each type of card, there are 15 cards. So now we need to find the probability of getting a card of red color. So red color king. So a king of red color. So in each card, each type of card, there are only one king. There is only one king. So if we divide this card into 4 groups, then for red king we have only 2. As you can see in the picture, there are only 2 red color king cards. So now there will be 2 kings of red color. So the number of outcomes favorable to A will be equal to 2 over here. So the probability of event A will be equal to the number of favorable outcomes divided by the number of possible outcomes. So that is equal to 2 by 52. So if you simplify, it will come 1 by 26. Now the second part. Find the probability of getting a face card. So let B be the event of getting a face card. So which are face card? Face card are Jack, King and Queen. So in each category there are 3 face cards. So there are 4 categories. So there will be 3 into 4, that is 12 face cards. So let B be the event of getting a face card. There are 3 face cards or each type in each of the 4 types. So number of outcomes favorable to B will be equal to 4 into 3, that is equal to 12. So the probability of event B is equal to 12 by 52. Now if you simplify, we will get 3 by 13. Now, next question. Find the probability of getting a red face card. So, let's see be the event of getting a red face card. So, let us again see the cards arrangement. So, red face card. So, Jack, King, Queen, these are the face cards. So now we have to separate only the red, we have to identify only the red face cards. So in each type there are three face cards and there are two red type cards. So the total number of red face card will be equal to 6. So there are three face cards in each of the two red cards. So number of outcomes favorable to C is equal to 2 into 3, that is equal to 6. So probability of event C is equal to 6 by 52, that is equal to 3 by 26. Now next part, the probability of getting the Jack of Hearts. So let D be the event of getting the Jack of Hearts. So now we have to find the Jack of Hearts. So there is only heart type of card is only, there are 13 heart cards, but out of that Jack of Heart is only one. So there is only one Jack of Hearts. So number of outcomes favorable to D will be equal to 1 by. So number of outcomes favorable to D is equal to 1. So the probability of D equal to 1 by 52. Now next part, the probability of getting a spade card. Let E be the event of getting a spade card. So spade, there are enter row is the spade. So how many spade cards are there? 13 spade cards, right? So now the number of outcomes favorable to E will be equal to 13. So the probability of E equal to 13 by 52, that is equal to 1 by 4. Now the last part, the probability of getting the Queen of Diamonds. So let F be the event of getting the Queen of Diamonds. So Queen of Diamonds, in diamond card there is only one queen. So the number of favorable outcome will be equal to 1 over here. So the probability F is equal to 1 by 52. Now we will discuss on finding the probability of sum based on year and sum based on leap year. Now the first question is, what is the probability that an ordinary year has 53 Sundays? So ordinary year they have mentioned, that means non-leap year. So how many days are there in an ordinary year? So we know that there are 365 days. So now let's find the number of weeks in 365 days. So we have to divide 365 days by the number of weeks, that is, we know that 1 week is 7 days. Now we have to find the number of weeks. So 365 divided by 7, then we will get the number of weeks over here. So let us do the division. So 7 5 is 35, 1 15, 2 14, 1 will be the remainder. So there are 52 weeks. Now there is 1 day extra, right? So 52 weeks and 1 extra day. So in 52 weeks, every week there has to be a Sunday, and 52 weeks. So how many Sundays will be there? So in 52 weeks there will be 52 Sundays. Now from where we will get 53rd Sunday? Because they have asked for 53 Sundays. So there is one extra day. So that day can be Sunday, can be Monday, any day, right? But if it is Sunday, then we will only get that 53 Sunday. So the possible outcomes for one extra day are Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So one extra day, that could be any day between Monday to Sunday. Now total number of possible outcomes is equal to 7 over here. Now let A be the event that the extra day is a Sunday. So outcome favorable to A is Sunday. So number of outcomes favorable to A will be equal to 1 because there is only one Sunday. So probability of event A is equal to number of outcomes favorable to A divided by total number of possible outcomes, that is equal to 1 by 7. So the probability that an ordinary year selected at random will have 53 Sundays is 1 by 7 because 52 Sundays is fixed. Now that one day extra, for that the probability is 1 by 7. Now next question, what is the probability that a leap year has 53 Sundays? So in a leap year we have how many days? 366 days, right? So, and here they have asked that we have to find out 53 Sundays. So let's find the number of week in 366 days. So let's divide 366 days by 7 days, that is 1 week. So now let's do the division. 7 5 is 35, 1 6, 7 2 is 14. So 2 will be the remainder. So there are 52 weeks and 2 extra days. So 52 weeks and 2 extra days. So in 52 weeks, in each week we have one Sunday. So 52 weeks we will have 52 Sundays. So now from where we will get the 53rd Sunday? From the 2 extra days, right? So 2 extra day may give us an extra Sunday, that is 53rd Sunday. Now the sample space for 2 extra days means what are the possible combination? Okay, so 2 extra days will be obviously the consecutive 2 consecutive days. So all possible outcomes are Sunday. It can be Sunday Monday or Monday Tuesday or Tuesday Wednesday or Wednesday Thursday or Thursday Friday or Friday Saturday or Saturday Sunday. So now the number of possible outcomes here is 7. Now let A be the event of getting the 53rd Sunday in the remaining 2 days. So in which days of combination we can get the Sunday? That is Sunday Monday we will get one Sunday and in Saturday Sunday. So the favorable outcomes to A is here Sunday Monday and Saturday Sunday. So number of outcomes favorable to A is equal to 2 over here. So probability of event A is equal to the number of outcomes favorable to A divided by total number of possible outcomes, that is equal to 2 by 7. So the probability that a leap year selected at random will have 53 Sundays is 2 by 7. Now the next topic is finding the probability of sum based on 3 horses. Okay, let us take a look at the question. 3 horses A, B and C are in a race. A is twice as like to win as B and B is twice as like to win as C. What are their probabilities of winning? Okay, so let us take a look how we are going to solve this problem. So let us consider the probability of the horses A, B, C, B, PA, PB and PC. Now the condition given here is A is twice as like to win as B. So the probability of A is equal to 2 into probability of B. So that is the probability of winning of A is equal to twice the probability of winning B. Now B is twice as like to win as C. So probability of B is equal to 2 into probability of C. So we got two equation over here. Now we substitute 2 in equation number 1. So what we got? PA equal to 2PB. So now replace PB value. So we'll get 2 into PC. So we got PA equal to 4PC. That is equation number 3. Since we don't know anything about the ability of the horses, so probability of horse A winning the race, or horse B winning the race, or horse C winning the race are equally likely to occur. So here we have considered that they have the equal chances. Hence they are elementary events. So since they are equal chances, so elementary events. So we know that already we learned that the sum of probabilities of elementary events is equal to 1. So if we add up all the elementary events, that is getting chance is 1 in all three cases. So either A can win, or B can win, or C can win. So they have equal chances. So the if we add up, we will get 1 over here. Now assuming only one of them is going to win the race. So PA plus PB plus PC will be equal to 1. Now replace the values. So in case of PA, it will be 4PC plus PB. Let us replace with PC, that is 2PC, and PC will keep it as it is. Now that will become 7PC equal to 1. So probability of horse C winning the race is equal to PC equal to 1 by 7. So now we are going to substitute the value of PC in equation number 3. Then PA will be equal to 4 into PC, that is 4 into 1 by 7, that is 4 by 7. So the probability of horse A winning the race is equal to 4 by 7. And now we substitute the value of PC in equation number 2. So PB equal to 2PC. So that is 2 into 1 by 7. So the probability of horse B winning the race is equal to 2 in 2 by 7. Hope it is clear. Now the next topic is finding the probability of sum based on birthday. So let us take a look at the question. Savita and Hamida are friends. What is the probability that both will have the same birthday, different birthdays, ignoring a leap year? So here we will consider only the normal year. So let us take a look at the solution. So all possible outcomes are, this is a, we are going to consider a normal year. So where we'll have 366 days, right? So let us consider that Savita's birthday is on 1st Jan, that is the first day of the year. And Hamid, so if they are having the same birthday, so that means Hamida's birthday is also on 1st Jan, that is the first birthday of year. So then only they will have the same day, same birthday in the same day, right? Same day birthday. Now it can be 1 1. Hamida's birthday is on the 2nd Jan, that is the second day of the year. So that then what will happen if Savita's birthday is on 1st Jan and Hamida's birthday is on 2nd Jan, then they will have the birthdays on the different day. So the possible outcomes are 1 1 and 1 2. Now if the Hamida's birthday is on 3rd Jan, that is the third day of the year, then also they will have a birthday on the different days, right? So in this way it will go on. So Hamida's birthday, if Hamida's birthday is on 31st December, that is the 365th day of the year. So what are the different possible outcomes? That is 1 1, 1 2, 1 3. In this way it keeps on going till 1365. Now if I consider that Savita's birthday is on 2nd Jan, that is the second day of the year, then Hamida's birthday can be the 1st Jan, that is the first day of the year. So now it can also happen that Hamida's birthday is on 2nd Jan, that is the second day of the year. Or Hamida's birthday can be the 3rd Jan, that is the third day of the year. So in this way, the other combination are 2 1 2 2 2 3. In this way, 2 365. So in this way, 3 1 3 2 3 3 3 365. So if it keeps on going, right? Now the last case could be the 365, like we are considering the Savitas at 365 fifth day, and the we have to consider the Hamida's birthday could be any day between 1 to 365. So these are the possible combinations. So what we got, that there are 365 rows. So in between we have given dot dot because we couldn't write all of them, right? So there are 365 rows, and each row is having 365 columns. So the total number of possible outcomes over here is 365 into 365. So now we have to consider the first question, that is the probability that they will have the birthday on the same day. So let A be the event that both Savita and Hamida have their birthday on same day. So if we observe all the elements on the diagonal, we observe that both their birthdays fall on the same day. So now if you take a look, that 1 1 1 2 3 3, so in these cases till 365, so that is the last day of the year. So if they are having both the birthdays on the same day, then just the diagonal ones are having the birthday on the same day. So since there are 365 rows and there are 365 diagonal elements, so the number of outcomes favorable to A is equal to 365. So probability of event A is here, that is the number of favorable outcome to A divided by number of total outcome. We can also represent it as NA by NA. So N represents the number of outcomes. So number of outcomes of A divided by number of total outcomes. Total outcomes we represented with S. So that is 365 divided by 365 into 365. So earlier we have not calculated the value of 365 into 365 because that will be a longer value, and during calculation you can do the mistakes. Better we keep it as it is, 365 into 365, then we can easily cut out these values. So it is coming 1 by 365. Now the second part of the problem, that the probability that they will have birthdays on the different days. So let B be the event that both Savita and Hamida have their birthdays on different days. So number of outcomes with birthday on different day is equal to the total number of outcomes minus the number of outcomes with birthday on the same day. So whatever the total number of birthday outcomes, total number of birthday with different day, so that will be equal to the total, whatever the total number of outcomes minus the number of outcomes are with birthday on the same day. So same day we already got how many outcomes are there. So that NB is equal to 365 into 365 minus 365. So we can take common 365, then that is 365 minus 1. So that is equal to 365 into 364. So number of outcomes favorable to B is equal to 365 into 364. So the probability of even B is equal to NB by NS, that is equal to 365 into 364 divided by 365 into 365. So now we can cut this 365 in numerator and denominator. We will get 364 divided by 365. I hope you understood all these problems, right? Now we are ending the video. So thanks for watching this video. If you liked my video, the way I have explained with each detailed way, the animated way, I hope the animation will help you to understand the problem better. So I tried to present all the animations, how to display the card problems, and what are the different outcomes of dice. So I tried to do it with the animation, so that it will help you to understand the problem. So I hope you liked the video. If you have understood and liked the video, please just hit the thumbs up button. And if you have any query regarding whatever I explained, or if you have any doubt or any other problem you couldn't understand in probability, you can write it in the comment section. I will always reply to your comments. Okay. And if you like my video, please do share this with your friends so that they can also watch and they can also get benefit just by watching. There is only you need to watch, you don't need to pay anything, right? So you need to watch and you will get the knowledge. And if you want to get more updated videos that will be coming not only in probability chapter, there are other chapters of CBSE board grade 10, so that I will be giving you shortly. So please subscribe to my channel, then you will get all the upcoming videos notification. So for that, just hit the bell icon. Okay. Hope you like my video. Okay, that's all for today. So thanks again for watching my video. Okay. Bye.